Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and your friends' friends. That's one way you can keep me going, inspired and refreshed of this very tireful work or job. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. This series of example problems in this video are all about couples. So the concept on couples is in my other playlist in Statics, your one-stop channel or course. If you want the concept and theory of on couples. So let's have problem 83. Determine the resultant torque of the two couples shown. So we have the first couple of force 150. The sense is clockwise, while the sense of these couples here, 50 and 50, leftward, rightward, is counterclockwise. Let's just assume that the moment of the 150 Newton couple is, or force is greater than the 50 Newton couple, or 50 Newton forces in this second couple. So let's find the distance between the 150 Newton forces, and it is equal to this, and it is equal to, that's the perpendicular distance, hypotenuse 0.2 sine 45. So considering clockwise positive, torque is 150 times 0.2 sine 45 minus 50 times 0.2, because this is 0.2 meter. So the value of the torque is 11.21 Newton meter. Since it is positive, our assumption that the torque is clockwise is correct. Now for your part, the drive shaft from the engine applies counterclockwise torque as viewed from the front of 1.8 kilonewton meter. So the torque developed is 1.8 kilonewton meter. To the propeller of the aircraft shown, determine the vertical reactions between the wheels and the ground at points A and B that are equivalent to this couple. So this is the aircraft. So show that the answers are NA 1.2 kilonewtons down and NB is 1.2 kilonewtons up. So that's for your part. Problem 84, still on couples. Six forces in the plane of the tabletop have the same magnitude F. They exert an 80-pound-foot couple, which tends to cause the table to turn clockwise when viewed from above. Determine the value of F. So let's draw the figure from above, or let's see the figure if we are positioning at the top of the table so that we can analyze it well. So this is the figure. So we have six forces of magnitude F, and there are three couples. This is the first, second, and this is the third. So the diagonal, the length of this diagonal is square root of 30 square plus 20 square. So I will not show it anymore. Use your calculator there. Square root of 30 square plus 20 square is 36.056 inches. This angle is arctan of 20 over 30. I will not show also that. That's 33.69 degrees. And this is the perpendicular distance between these two diagonal forces. So the moment arm or lever arm of this force, so that the lever arm of this couple is 36.056 sine of this total angle here, which is 33.69 plus 45, that's 78.69. So 36.056 sine of 78.69. So use your calculator, it is equal to 35.356 inches. Therefore, the couple, which is 80 pound-foot, and take note, if F is in pounds and the distance is inches, so we multiply 80 pound-foot to multiply this by 12 so that we have the same uh, units. So F times 35.356 clockwise positive plus F times 20 inches, then this is counterclockwise minus F times 15, then equals 80 pound-foot times 12 to convert it to pound-inch. So it is now consistent, so F can now be computed 23.79 pounds. So for your part, determine the pair of vertical forces acting at ends A and B that are equivalent to the two couples shown. So this is it. Then I want you to show that the torque is, the forces at A and B vertical is 28.02 newtons up and at B 28.02 newtons down. '85. Two cables that pass over smooth pegs in the disc carry the tension shown. The force system exerted by the cables on the disc should be equivalent to a clockwise couple whose magnitude is 500 Newton meter. Determine the minimum value of F and the corresponding angle alpha that will give the required couple. So here is the given figure so that we can analyze it well. Let's do the top view. So this is the top view. The radius is 300 mm or 0.3 meter because the diameter is 600 mm. So that's the top view. So this horizontal distance between the 400 Newton force is 0.3 sine 45. So that's 0.3 sine 45. So that F will be minimum, then F and this moment arm, these two, must be F, the line of action of F must be perpendicular to this distance, because this is the maximum perpendicular distance. For F to be minimum, F should be perpendicular to that, or else it will not be minimum. It will have a greater value because the distance will decrease. So square root of 0.3, this is radius 0.3 square plus 0.3 square is 0.3 square root of 2 as shown. So take note that F must be perpendicular to this line. So therefore torque, this is clockwise, and the direction of the 400 Newton couple is 400 Newton forces in the second couple is also clockwise, so we add. So torque F times 0.3 square root of 2 plus 400 times 0.3 sine 45 is equal to 500 Newton meter. So from there we can now compute the minimum F, and it is equal to 978.5 newtons, and the corresponding value of alpha, because this is 45, alpha should also be 45 degrees, so that 45 plus 45 is 90, and F is perpendicular to this moment arm or lever arm. So alpha equals 45 degrees. For your part, two cables that pass over smooth pegs in the disc carry the tension shown. Knowing that F is 300 newtons and that alpha is 30 degrees, determine the couple M that is equivalent to the force system exerted by the cables on the disc. So show that the moment or torque, net torque, is 207.8 Newton meter clockwise. Problem 86. Determine the magnitude of the resultant force R and the horizontal distance x from A to its line of action. So since the greater force is 9 kilonewtons, the resultant is upward, and it has a net value of 9 minus 6. So let's put the resultant, let us say, somewhere between A and B. That's just an assumption. That's R, which is 9 minus 6, so R is 3 kilonewtons upward. Let's put it there. And the distance of R from A is X. So take note that the components of the 3 kilonewton force are 6 and 9, where 6 is downward and 9 is upward. So the moment of the resultant about A is counterclockwise, 3 times X. That should also be the sum of the moments of its components. Since we make A as our reference point, the moment of the 6 kilonewton force about A is 0, and the moment of the 9 kilonewton force is also the same sense as that of the moment of the resultant, but it is 9 times 4. So 3 times X counterclockwise equals 9 times 4 counterclockwise. Solving for X, X is 12 meters right of A. So don't worry about the figure. It should be somewhere here so that the system will be equivalent. The original system will be equivalent to this new system with a force 3 kilonewtons and 12 meters from A. So for your part, determine the magnitude of the resultant force R and the horizontal distance X from A to its line of action. So here is the given figure. Show that R is 14 kilonewtons downward and its distance from A is 3 meters right of A. Problem 87, still on couples. Determine the magnitude of the parallel components at A and B of the force system shown. So the parallel forces, so at A and at B, since this is 9 kilonewtons, so the forces at A and B must be different, and one should be downward, the other should be upward. So we will call the force at A as FA and at B as FB. So FA is downward and FB is upward because the moment of the original force 9 about A is 9 times 3 and it is counterclockwise. So FB, the moment of FB about A is also counterclockwise. So FA minus FB equals 9, going down positive because FA is downward and this resultant is also downward. So that's the equation, first equation. Then moment about A is 9 times 3 counterclockwise. That should also be the moment of FB about A, FB times 6 counterclockwise. So from there, FB can now be solved. FB is 4.5 kilonewtons upward. So FB is 4.5 kilonewtons upward. Substitute here. FA minus 4.5 equals 9. So FA equals 13.5 kilonewtons downward. So these are the answers. Then for your part, determine the magnitude of the parallel components at A and B of the force system shown and show that these are the answers. FA equals 4 kilonewtons downward and FB is 6 kilonewtons downward. So that's it. And I hope that you will learn from this video.